Ready to go? Good morning, everyone. Thank you for coming in so early. I hope you guys had a great time in the after party yesterday. But I'm so happy so many of you made it in the first session of the day. All right. My name is Jay Kapadia. I work for a company called IQVIA. I lead the engineering team for a product called Orchestrated Customer Engagement. And we're going to talk about the iPad app we built for going live with the product. I'm here with Lynn Cohen, who is from Salesforce. She is our partner in crime. So a lot of these decisions, she would be able to answer better than me sometimes. All right. For those who don't know who is IQVIA, IQVIA is a healthcare technology company which was formed by a merger of two very large companies in healthcare, IMS Health and Quintiles. We were formed with a mission to take healthcare forward using data science. And we help the companies take a molecule in its conceptual stage to market using our research and development capabilities, in clinical development and trials. We also help life sciences companies prove their products' efficacy, their drug efficacy with real-world evidence and data. We also help them take their product to market, their drug to market, to how do we align their territories to all the way to incentive compensation of the field sales. Last but not the least, we have a portfolio of technology products which we use to do all of the above. And I work part of the team. Roughly a year back, we formed an alliance with Salesforce, mainly with a strategy that we did not want to reinvent the wheel at an infrastructure and a platform level. Our core strength is to help take molecule to market, not to build great infrastructure and hardware and software. So we did a global alliance with Salesforce. With Salesforce, we got global scale and capability to take our products faster. Just now, we are building the orchestrated customer engagement on it. We are also building a virtual trial system and a patient referral system on Salesforce. Before we move forward, I just want to do a quick survey of the room. Who here has built managed packages on Salesforce? All right, 20%. Who has built a mobile app on Salesforce? Wow. And who has built a fully offline mobile app on Salesforce? Two. That's good because this is for folks who want to and learn who want to learn how to build a fully offline app on Salesforce. All right. This is what we are going to talk about today. A little bit of a problem statement, why orchestrated customer engagement. We're going to talk about the goals with which we started our development, a little bit of the app architecture, and then we are going to start peeling the onion a little bit. Our app architecture is divided into 4 parts of a two-way sync, a metadata layer, a dynamic UI, and a mobile database. Because we only have 30 minutes, we are only going to talk about metadata and the dynamic UI. The two-way sync and the mobile database is probably a session for Dreamforce, which I would love to do if possible. But today we are going to talk about how we drove our iPad app using all the metadata Salesforce provides and the dynamic UI as well, and then some key takeaways. All right. Why orchestrated customer engagement? Every single healthcare client we went to, they told us 2 messages very clearly. How do we stay compliant with ever-changing government regulations, GDPR, GXP, Part 11, things like that? And how do we create a consistent brand in the market? Today in healthcare companies, there are silos in terms of departments in healthcare companies, like medical affairs, sales, marketing. And they all have their own applications, which are siloed as well, which is leading to an inconsistent brand and confused patients and doctors. So with a goal to bring down the walls, create a consistent brand in the market, we decided to create OCE. This is a very high-level, big-picture architecture of OCE. We basically use Salesforce.com, Marketing Cloud, and Heroku to do the big parts in the application. We created our own UI layer for iPad, which is very healthcare-centric, which we call Apollo. We created an intelligence service to give some intelligence to our apps so the app works for our users and not the users for the app. We call it ADA. And then we created a data integration layer using all the APIs available from the platform, which is very, very healthcare specific. It lets us exchange data, data of doctors, data of calls and marketing elements and things like that. We call it Lexi. We today are going to talk about the iPad app, which is being built for Michael, Peter, and Priyanka over here, and they are the people who talk to the doctors face-to-face and sometimes patients face-to-face. And this is the app which they use on a day-to-day basis. Roughly, they use it 9 times. That is our user research. 9 to 10 times a day they are in the app doing something. All right, what were the goals of our iPad app? Let's focus on the iPad app a little bit. Due to the use of the iPad app, we needed it to work in a no or a low internet zone. Low internet zone is more important than no internet zone because people don't go in airplane mode, but people go in zones which is very less network. The app needed to work in that. We needed an app which just works, right? We didn't want an iPad app which our customers has to configure again. Our configuration needed, was needed to make our Lightning app, the online app work, needed to drive our iPad app. We didn't want to create a separate configuration. We needed the app to work in 30+ languages and 30+ countries. We had a lot of compliance requirements. We needed to capture electronic signatures sometimes. We needed to ensure that the call record never gets lost. The children, and by the way, when I say call record, it means face-to-face interaction. This is just healthcare lingo of saying call. But in the face-to-face interactions, we wanted to make sure that our children never gets disconnected. So if I have a call and then I say I talked about this product, they never get disconnected. There is regular requirements around that. We had to ensure that we lock down certain fields once the signature is captured. So there were a lot of compliance complexities which we had to handle at the iPad level, including 0% data loss. We had and absolutely, if you lose data in this world, you had to actually go to FDA and fill in a report, which is a very expensive thing to do. So we had a very complex compliance requirement. We had to support product configuration, customer configuration, and a lot of customers had multiple countries going live in the same org. So in the iPad app itself, we had to support different reps of different countries, which may have different profiles. So in short, we had to support profiles and permission sets in the iPad offline. And because our strategy was to partner with Salesforce, we wanted a faster go-to-market and wanted to reuse Salesforce platform as much as possible. All right, this is the high-level app architecture we came up with. This app is a fully native Swift app written with iOS technologies. Swift 4 was our language. We basically divided it into 4 parts. If you see at the top level, there is a full-fledged synchronization engine built with Salesforce SDK and Amazon SDK to do some big data things we wanted to do. We have a metadata service layer, which basically tried to gather and package all the metadata we needed for the iPad to work. We had a custom UI framework, which made the UI work like Salesforce, so like Aura components and page layouts and Lightning pages, we had that. And at the bottom, we had a very rich mobile database layer, which we built on SQLite. We used an open source layer called FMDB. It is a wrapper around SQLite, and If you guys know what is object relationship mapping layer, it is used basically to get granular access to define the data, right? Because of our requirements, we could not ship an app with the database inbuilt. The database was there, but it was empty. And every time we would download metadata, we would say, oh, this user needs accounts, this user needs calls, this user needs MRF. And depending on that, we would create the database on the fly when you sign in first time. And I'll show you how we accomplish that very soon. But again, I know you guys would love to know our experiences around sync and mobile database, but that's a session we will do at Dreamforce if Lynn allows us to. All right, let's move on to the metadata layer. So at a high level, what are about our goals? So before I move forward, for both layers, metadata and UI, I'm going to talk about it in 4 different ways. We are going to talk about the goals. We are going to talk about the design decisions we took to make that happen. Then I'm going to show you guys a little demo. And then I'll show you some code snippets and some metadata configuration we have for that demo. All right. Metadata, what were our goals? We wanted 0% zero disruption in the app. Meaning, if an administrator moves in a chain set with a field created on an object which is mandatory and forgets to change the page layout so that a rep can enter it, we didn't want the app to break. So we needed a point where an administrator can say, hey, I'm ready, push this out to my field. We wanted to version so that we can roll back. We wanted to package so the sync is fast and it just works. So there are so many such apps available. Performance is one of the features which can make you win, and we wanted it to work as fast as we could. We wanted to ensure that our clients can override our translations. We are in 30 countries, and every customer talks about, we call it call. In US itself, we have a customer who calls it interaction. In US itself, there is another client who calls it something else. So we needed our clients to override our translations we provide out of the box. We needed it to be reusable so that customers can use Salesforce platform capabilities and change it, and we can go to market faster just using those platform capabilities. Last but not the least, again, it was speed, speed, speed. It was all about performance for the app to work. Let's talk about design decisions we took. First major design decision was a Heroku metadata service we made. We basically created a Heroku metadata service which upon when the administrator, just like I said, is ready, he would say, hey Heroku service, create my metadata for the field. It would query, it would call metadata API, reporting API, and REST API, and it would query Salesforce and gather all the metadata. Second step it did was to decorate it. By decoration, I mean is this metadata APIs are a lot. Every page layout is a separate JSON. Every permission set is a separate JSON. So we basically gathered everything and made like 4 or 5 files out of it and changed it a little bit so that our iPad app could work easily. And part of decoration is also making it performant. So we kind of made the JSON in a way that we could ship it faster. One of the key things around this decoration, which was very much appreciated by customers, was around formula fields. You guys all know we can create formula fields on our objects, right? You guys also know we can create validation rules around our objects, right? What we did is we queried that metadata from Salesforce using our Heroku service, and we wrote some code to convert those formula fields into abstract syntax trees. And that is just a computer science way of making like a big tree of if-else statements to execute it. And then we executed those JSONs offline. So for example, most apps, when you have formula fields, it would be, if you change the dependent fields, it would go online. When the data sync comes down, it will bring down the new data of that formula. We don't have to do that. As soon as you change the field, we execute that abstract syntax tree and give you the result offline. Right? Same with validation rules. It's the exact same theory with validation rules. Some more design decisions. So we packaged translations, custom metadata, Salesforce metadata, custom settings, tabs, profiles, and permission sets, everything into these decorated files and sent it to iPad for parsing. One more design decision for you guys, which you'll have to all worry about, is how do we parse these JSONs? Like, how do I encode it? How do I decode it, right? Because these things come down in a format. How do I make it Apple-oriented, right? So we used a library called Codable. It's an Apple library. We found that was the most performant library to encode and decode JSONs. Last but not the least, translations and permission sets. Some of you guys may be thinking, hey, you have this Heroku service. Assuming it's called as an administrator, how do you lay out translations on it? Because if you are calling it as an admin, you will get all the fields in the page layout. You will get the translations as English, assuming administrator as English as his language. How do you do that? So when we download this metadata, we process it. We use permission sets and profile information, and we use our translation files and apply it right then and there on the layout. So an iPad user, when they lay out, they see it in their language. So once more, translations and permissions are applied during metadata processing on the iPad. All right, so let's look at a little bit of a demo real quick, if I can make this work. All right, this works. So this was our Lightning app, right? This is what our customer sees. This is a ground-up Lightning app we built. We have no classic UI, so to say. We basically, if you go on our home tab and see, we have an app called OCE. We have these tabs aligned here. And we have a custom Aura component called NBC. We have used the dashboards and reports to lay down this charts over here. Now, if I go to our iPad app, if you see over here, we have the home tab, accounts, we have planner. These are the same tabs you see online as well. So, and we do have some capability to make custom tabs, but I'll show you why and why did we do that as well. So this is our offline app, just so that we call this Apollo UI. We did this to create a brand around our healthcare presence. This is the same component, if you will, you see over here in the Lightning app. We have an Aura component here, a Swift component in iOS. Then we have actually called the reporting API and parsed this particular dashboard, which was added to the home page, and showed it over here on the iPad as well. All right, so how do we do it? Let's go through our metadata structure a little bit. So we decided to package our metadata structure. So the first folder is UI, where we kind of send some UI-specific code to render dynamically. But that is just code, so that doesn't provide any dynamism. What is important is all the files below it. AST is our abstract syntax tree. We have custom metadata tabs, database, reports, profiles, layouts, and specification. Let's go to it one by one. All right, so this was our nav JSON. We call it navigation JSON. So the tabs you saw on the iPad app, how it came the same, and the tabs on Salesforce.com app, came from this particular JSON. If you see, there are 3 different types of tabs we have. One is a custom tab. We required a way to render custom tabs for things which were not relevant on Salesforce. For example, showing a video to a doctor. Nobody's going to go on the website and show a video. So we needed a way to have a tab called CLM, which is iPad only. There was no Lightning thing. So we created a custom metadata structure to say tabs, and we could do custom tabs. Then if you see the second one, that's the standard home tab. And if you see right below there, there's a type flag. It's called flexi page. That is what indicates to the iPad, hey, this is a flexi page on the home page. Render it like that. And the third one, if you see, the accounts tab is an Aura component we built on Salesforce. We read that, we say, oh, if this is this Aura component, render the Swift controller like this. So we have all this JSON, which we query out of different metadata, which comes in, and package it like this. iPad reads it and renders it. A lot of this code was written just once, and then as new features were built, we just had to add tabs, and we had to do Salesforce config, and it just worked. All right, abstract syntax tree. So this is a little bit, I'll show you guys one particular demo on this one. All right. So if I go to accounts, open up Abbott Howard, go to details. If you see the speaker goals over here, this is a very simple formula. If I change this to 7 and save, the number here becomes 13. So it's just doing a 20 minus 7, 13. So this is kind of the formula which is being rendered offline dynamically. Again, if I do it 8, this would become 12 as well. So and one other thing I want to show real quick was we also render it in a custom way, which is if you see this green tile out here, this is showing that the same 12, which is there in the details tab. So this is a page layout, which is rendering a formula field using the abstract syntax tree which we have over here. So this is the abstract syntax tree for the formula I just showed you, which does a subtraction between two fields to give you another numeric value. This is a much more complex formula which calculates age from your birth date and today, and it does like a negate impression, and it does some if clauses. So we actually parse all this in Swift to render these formula fields. So once again, you make formula fields and validation rules on Salesforce, it just works on iPad. You as a customer does not have to worry about, oh, okay, will this render on offline? A lot of times, a lot of your validations for compliance reason, is this doctor eligible for taking a sample, is dependent on large formulas. This is how we solved that challenge. Moving on, config JSON. So we have a lot of us uses custom settings, hierarchical custom settings, and custom metadata and things like that for configuration. So we basically read all of that through metadata, gathered it, and put all the profiles, listed down all the profiles which are necessary, and just sent it to to iPad. So just like you would write an Aura component which would see, hey, if this custom setting is on, do this, we would write Swift code to do that as well. So on both sides, the experience is exactly the same. You turn it on, and it just works on both sides. This is another thing which I would like to spend a couple of minutes on is our critical database JSON. As I said before, when we ship the app, we don't give tables in build. We create the tables on the fly. When you first time sign in, we create tables. How does the iPad know what tables to create? It is this metadata which tells them. So this particular JSON does 2 or 3 things. The first thing it says is, hey, if your profile is this, then you need to create an account table in your SQLite database. That's one. The other piece it tells you is also that, hey, you have to sync data into this table using Salesforce, and we used composite APIs to do that. When we fired the SOQL, we needed a where clause because we didn't want to download the entire universe of Salesforce onto iPad. It would pretty much kill it, right? So we had added a where SOQL clause here, which is a little bit of custom addition we did to Salesforce metadata. And we basically gave them a where clause with some parameters saying, hey, download accounts only of your territory to your iPad, something like that. So once again, this JSON tells what tables to create, and when you query Salesforce, what is the where clause you need to apply to your SOQL queries. Let's move on to permission sets. So this is how we decorated permission sets and profiles. We send down all the permission sets and profiles in our metadata package, and depending on your profile, it gets applied to your Salesforce. All right, so a little bit of S objects. So if the database JSON was telling you what tables to create, S objects JSON is telling you what fields to create in those tables. So we have kind of default values, uniqueness checks, all that metadata gathered at one place, and we send it to iPad so we can apply. This is this Swift code we created to encode and decode JSON files, another Apple library. All right, a little bit of learnings. There are just two learnings, gotcha moments, so to say. If your customers override translations of S objects, which you deliver in your package, Metadata API does not return it. So you will have to find we found a workaround by actually calling the package.xml on the fly and parsing that XML file to figure that out. So one gotcha moment. And this came up way late in our testing, saying, how do we do that? So testing is a good lesson learned. And then standard field translations. So Salesforce provides standard field translations for its own objects, right? Accounts, leads, opportunities. Those translations, if you don't override them, you like them, and you want to reuse them, they don't come in your metadata API. So we kind of found out a hack where we created a dummy Visualforce page, and we added all those fields in its controller, and then called that page to get the translations and push it in our metadata API. Another hack, contact me if you guys face this roadblock. It's just something we work with Lynn on an ongoing basis. All right, user interface. Obviously, user interface is one of the most important things nowadays. Everybody wants their app to be sexy, right? Performant, modern. So that was one of our goals, obviously. But we also wanted single configuration, Lightning pages, page layouts, just make the iPad app work. We did not want to reinvent the wheel on reports and charts on the iPad. We wanted the reports and dashboards, which you make in Lightning, work in the iPad app as well. And last but not the least, again, translations from the server, not hard-coded in the iOS app. We wanted translations to come down. All right, some design decisions on user interface. So we did a lot of work in writing the UI renderers, right? Like the reports renderer, page layout renderer, the Flexi Lightning page renderer. We did a lot of work to just render those pages, looking at the JSON, just render it offline as well. So using that, we did homepage, we did reports and dashboards, we did Lightning pages, we did compact layouts, which come in the highlights panel of Lightning page. That also we rendered dynamically. We did page layouts. We even figured out a way to render lookup filters and dependent lookups, which are now available in Metadata API, which kind of makes your life much easier. You don't have to create custom UIs for that. But there is business always needs something custom, always, that they cannot stick to out of box, right? So we had to write some custom UIs. The key decision we took in custom UI is that even though the UI and interaction was custom, like for example, our call page updates 10 objects in one click. The key decision we took there is even though the interactions were custom, we made sure it's derived from a page layout. So the fields to be put there, the sections to be put there, the actions to be put there are still coming from a page layout, which made it simpler because then you can assign it to a profile and a record type, and it works. Otherwise, you have to figure out your own security around those custom UIs. We also built a bunch of, like the next best customer component you saw, we built just like our Lightning components, we built like roughly 125 Lightning components till date. We have 125 Swift components to do the same thing in our Swift app as well. Translations is something we rendered when we processed metadata, so we didn't have to worry about it. Last but not the least, we had a lot of requirements around flexible UI, which kind of can be collapsed and things like that. Autolayout was very tricky. I mean, for those iOS developers who have used Autolayouts, there would be some scar tissue here on that, right? So we used an open source toolkit called Snapkit, which makes the job of making a flexible UI much easier. All right, I'm going to do a quick demo. I am over time. All right, so Let's go to, if I go to accounts, you, if I go to accounts, you will see this custom, this is an Aura component we built in Salesforce. This is a full text search we built on iOS. If I click on an account, this is what you see. This is the Lightning page with the same tabs. This is a compact layout coming for the highlights panel. We built our own kind of our fidget spinner, so to say, to lay out Lightning actions. The actions, the buttons you have there kind of come down over here. And then we built out these Lightning pages. Some of these Lightning pages are just page layouts, right? Related lists. And we had our own way of rendering a related list rather than showing them just a grid, which was like boring. So like we decided to make cards and kind of make it some by status and things. We have some custom components like affiliations, like ratings. These are things which we did, which made business to our, which made sense to our business. Same thing over here. If I go to accounts, I would land on an Aura component which did the same kind of a search kind of a thing. If I click here, the same account in Lightning, which just works exactly the same way. All right. So some key things. So just like all the JSONs we talked about in metadata, this is one part of it, but I separated it out because UI is using it. We created like a decorated UI JSON for rendering our iPad app, which contained page layouts, flexi pages, compact layouts, list views. All the metadata was there. It is in like one large JSON, which we process initially when you sign in. A little bit on the page layouts. This was our business account page layout with its sections and UI metadata. Our home page layout, if you see here, you will see the NBC tab, NBC results, and the calendar view, and some other things around the dashboard. This was our reports and dashboards layout, which we rendered to show a custom report and the report metadata around it. This is how we use Snapkit. So if you do this in Autolayout, it's a lot of lines of code in Swift. We use Snapkit, and it was as easy as this. You just say make left equal to this, and it just resizes your UI. All right. Some learnings or user interface. Let's go about it one by one. When you are going with this route around, as you see online, you will see offline, there are some hurdles. There are differences in label values. For example, parent account on the account field, right? It looks parent account online, right, in Salesforce UI. But when you use Schema Describe metadata, it comes as parent account ID. So you will have to think about those UIs. If the customer wants it to be the same, you will have to think about some workarounds. If your customer decides to clone page layouts of S objects and not use your page layouts, they will not get it in the metadata API. So you will have to have a workaround. We actually queried the package XML of that org and figured it out that way. Standard tab translations, accounts, leads, opportunities, they don't come. So we kind of, that and the tabs inside Lightning page, like detail and dashboard and ratings, they are not translated. So we created a category in custom labels and used that route to translate them on the iPad. Related list metadata. So this is a funny one. So for Salesforce Objects, the related list metadata is really tricky. A normal related list, for example, if you wanted created by ID on a related list, what it would say generally is SObject.created by ID. That's the standard way. But for Salesforce Object, it comes as created by _name. And it broke our structure quite a bit, and we had to kind of figure out, saying, oh, Salesforce is this way, manage package is this way, and custom is this way. And then we had to write code for all three cases to handle them. Dashboard groupings, when you create 3 or 4 report charts in the single dashboard, even though the reports titles are translated, the dashboard doesn't. So you'll have to get that from the reports itself, not the dashboard. This is a bug. Salesforce has acknowledged they're going to fix it. And includes and excludes on lookup filters are not coming in the API yet. And I'm sure they're going to come very soon as well. All right, so key takeaways before we go on to our questions. I'd highly, highly recommend to use Salesforce platform. Don't create your own API layer just for the sake of it. Use the Lightning page metadata. Use the page layouts. It will absolutely enable your customers to go live faster, right? Forget about the less dev time. Your customers to go live faster. Build in resilience for Salesforce customization. Salesforce brings its processes and process builders and flows and triggers. So we thought quite a bit, we did a few design sessions with our customers to understand what customization they absolutely love. They absolutely love to create triggers, for example, right? They loved it. Those triggers are not well written, by the way. Now, if your sync is firing those triggers, it may start failing because that trigger is failing, or that trigger is taking too much time and it is throwing a CPU limit error. It will fail. Your sync will start failing, which is a big problem for us in terms of compliance. So think about, make your app resilient around that. One other thing we learned around translations is it's all about testing. Test. Like you have to test like at least 5 to 8 rounds of testing around different languages. There are Japanese characters. Japanese has 4 different types of accents, for example, and you have to test all that out. Last 2, I didn't talk about them a lot, but I'm just going to say it so that it is my continuation towards my next session is around when you're writing sync, remember nowadays, APIs can be faster than your iPad's performance. So what we found out, we used composite resources, and when we were downloading it from Salesforce was giving us faster data than our iPads could process. So faster API doesn't mean faster SQLite or faster iPad. That is what it is. You have to work with that. So we had to put a throttle in between to tell Salesforce, slow down, we are still processing, right? And sync, right? If you guys decide to write sync, it's a tough challenge. So you will go in with an expectation that as you find edge cases, you will have to redesign and refactor a little bit on the fly. So stay agile, and if you have to refactor, don't worry. Rewrite, don't worry. Sync is a tough challenge. So with that, please take a survey. I would love the feedback and make my presentation better next time. And I will open up with questions. There are 2 mics over here. Please come up and give questions. Thank you very much.
Hi, I had a question about specifically how you're implementing the formulas on the client side, because Apple has that limitation where they don't allow compiling on the device itself. So I was curious, when you're building out those AST trees, how are you then processing that on the iPad without violating Apple's restrictions?
Yes, so what we did is we actually, the mobile database layer, which we didn't talk about, actually in that layer, we have a set of Swift files. So when I query SQLite, it goes through a data access layer, and that data access layer actually parses that formula on the fly in Swift. It doesn't really parse it. It doesn't really parse it in the iOS, pre-parse it in the iOS. So that's a very true statement. Apple doesn't allow that, but we do it in the code itself at runtime.
They do allow interpretation, but they don't allow compilation.
Right.
Thank you.
Thank you.
So similar question. So with your formula engine, how did you solve the case where you had a formula field that maybe looked up, like traversed, 7 objects or something to look at a related field? Did you have to maybe go query data on the fly if you didn't already have that data resident in the application?
No, we made an assumption. We basically told our customers as a best practice that if you have a formula which is referring to a table, you'll have to configure it to come offline. We didn't go kind of query the APIs around that. We made an assumption like that. Okay. Like we wanted the configuration to be right for the formulas to work.
So whenever you're editing the field, right? So you're saying it changes in the local DB in the iPad first. And at the same time, synchronously, you make a call to the Salesforce, and then you tell that, okay, the change has been done?
No. All our changes just goes to the iPad. There is a separate kind of a daemon running on the iPad, which kind of syncs the data online, and we don't sync up formula fields. We just sync up the dependent fields up, and that formula is just takes care of itself.
So when I update something in the iPad, then it'll take some time. So asynchronously, there's a daemon running which sends a
No,
request.
it doesn't. So that is what I was saying. The formula is parsed offline. So
Okay.
so you will see the result. The online result will come when the data goes up if you have internet.
Got it. Good.
Cool. Thank you. All right. Cool. I think we're good. Thank you very much.